Methyl ethanoate is an ester. Draw the molecule and then draw a functional isomer and a positional isomer of this organic compound. So the first one is to just get the methyl, then the O, and then 2 carbons, the ethanoate. If I want to change and get a positional isomer, I just want to change the position of this functional group over here, which is your ester functional group. So what I'm going to do, instead of going methyl ethanoate, I'm going to go ethyl methanoate. And then that means that the functional group has changed position. If I need to create a functional isomer, that means I need to change the functional group. Now you need to always remember that esters and carboxylic acids are isomers of one another. So I've got 3 carbons all together over here, 1, 2, 3. So I'm going to put them in a row, 1, 2, 3 over there. And then I am going to put the carboxylic acid functional group on there, and then I land up with a functional isomer of that organic compound. What catalyst is used in the reaction to form methyl ethanoate? Esterification always uses sulfuric acid. They often ask for the name where you have to write sulfuric acid. Sometimes they ask for the formula. You must do the formula. This one was a bit vague. You could have given either. Use structural formulae to show the esterification reaction which results in the formation of methyl ethanoate. Name the reactants and the products. If it's methyl ethanoate, it's the alcohol first and then the acid. So it's going to be methanol and ethanoic acid, which in the presence of sulfuric acid will make methyl ethanoate and water. So let's draw that out. So over here we have got the methanol. Over here we have got the ethanoic acid, and that is going to form methyl ethanoate, which we've just drawn up there. And remember, if you're asked to do it with structural formula, you need to actually draw the structural formula of water as well. Butane is an where have I gone? Butane is an alkane molecule. Draw the molecule and then draw a chain isomer of it. Name the chain isomer that you have drawn, so you have to alter the chain. So let's first draw some butane out. So here's butane, 4 carbons along over there, and it's all single bonds. If I want to create a chain isomer, I'm just going to pick up that methyl group, let's say over there, pop it over here, and make that a hydrogen, and I land up then with methyl propanoate, because I've now only got a 3 carbon chain. What is a combustion reaction? That's bookwork again. It is the reaction between oxygen and anything really to produce carbon dioxide and water. You can use alkanes, alkenes, alkynes, at least alcohols. All of them undergo combustion. What is a homologous series? Again, bookwork, a series of similar compounds which have the same functional group and have the same general formula in which each member differs from the previous one by a single CH2 unit. 34 is a functional group, another definition that is bookwork, an atom or group of atoms that form the center of chemical activity of a molecule. Are butane and butene isomers of one another? Explain. No, because butane is C4H10, butene is C4H8. Those are not the same molecular formula, and therefore they are not isomers of one another. Using reactions between butane and bromine, differentiate between addition and substitution reactions, show both reactions using structural formulae. So if I put at least bromine onto butane, what's going to happen is I have to substitute. I may only substitute one of those bromines and then get hydrogen bromide out the other side. I may land up substituting 2 hydrogens. Maybe they're in one part of the molecule, maybe they're in another. The way that this question was asked, you could have answered a multitude of different answers. But if I were to name this particular compound over here, I would say that it is 1,1-dibromobutane. However, with butene, this also, it could have been but 1ene, it could have been but 2ene. They weren't specific at all, so we could have done a whole lot of things. But this double bond opens up, and I put the bromines on there, and we land up with, let's say, 2,3-dibromo butane at the end of it all. Use the flowchart below and answer the questions that follow. We are going to take propene and add bromine to it. We're going to open up and we're going to get dibromo propane. The dibromo propane needs to have the bromines on 2 different carbons, because you're opening up the double bond like you did over here. They can't both be on this carbon. They would be on 2 different carbons. Identify the type of reaction that occurs in reaction A, where propene becomes propane. That is an addition reaction or a hydrogenation reaction. Obviously, I must have added hydrogen to change the ene into an ane. The chemical reaction taking place when decane forms propene is called cracking. Define the term cracking and what other substance will be formed. You'll always get hydrogen being given off, but cracking is taking long carbon chains and breaking them into smaller carbon chains. The boiling point of propane is -42, whilst that of propanol is 97 degrees. Use your knowledge of intermolecular forces in order to explain why propane has got a lower boiling point than propanol. And what you're going to talk about is that propane is a nonpolar molecule, and therefore it has London forces, which are weak intermolecular forces. Therefore, it is easy to separate the particles. Whilst the propanol has got a alcohol group on it, and that alcohol group is polar. In being polar, you land up with either, you could have said hydrogen bond forces, or just dipole-dipole intermolecular forces, which are much stronger, therefore resulting in a much higher boiling point. If I now take 10 grams of propane, C3H8, and I react it with oxygen, I'm going to form carbon dioxide and water. I need to balance that reaction and the balancing numbers. First I look at the carbons and I balance out the carbons, then I look at the hydrogens and I balance out the hydrogens, and then I see what I can do with the oxygens, and sometimes I have to double and sometimes I don't. So the mass that I've been given here is 10 grams. Number of moles is equal to mass over molar mass. 10 divided by 12 times 3 plus 8, and that's 44. And I land up with 0.22 moles. They want to know how much carbon dioxide I'm going to get, so I'm going to get a relationship between the propane at 1 is to 3, 0.22 is to, if I kept it in my calculator, it looks like it should be 0.66, but actually it was 0.22 something or other, and it rounds up to 0.68. Then I'm working out the mass here. Mass is equal to number of moles times molar mass. By some weird coincidence, the molar mass of carbon dioxide is also 44, because it's going to be 12 plus 16 plus 16, and you land up with 29.92 grams of carbon dioxide. They could have asked you for a volume as well. You may have needed to have done that. Then you need to draw the structural formulae for the following compounds. So you have got eth, which is 2, ane, only single bonds, tetrachlora, there are 4 of them, ethane, and it's put on like that. Ideally, I suppose it should have been 1,1,2,2 tetrachloroethane. It would have been better. Pentanol, pentan-1-ol, the alcohol group is right at the end, 1, 2, 3, 4, 5 carbons. Methyl propene, propene has a double bond on the 3 chain, and the methyl group has to come off the middle carbon, because otherwise it would be a but something or other. H over there. Then you've got the propyl ethanoate, prop 1, 2, 3. That's your propyl group, and then the oxygen joining, and then ethanoate over there. Explain how hydrogen bond intermolecular forces come into existence. They are a result of small molecules close together with strong dipoles, therefore unusually high intermolecular forces. What are my hydrogen bond forces? It's hydrogen fluoride, small molecule with a high electronegativity, hydrogen oxide, which we call water, small molecule, small hydrogen, high electronegativity, and ammonia, which again is small with a strong dipole. Those are classic hydrogen bond force molecules.